We've done so much in pre-calculus of solving. You have to learn how to solve everything. So I will show you a nice way to check it. And you'll be like, oh, well, that's easy. Now I know I did it correctly by checking it. But the general rule is to take a log or an ln of each side and use the power rule to isolate the variable. Take the log or ln of each side and use the power rule to isolate the variable. Okay. So here's an example of 7 to the x equals 12. There's several ways to do this, honestly. I could show you one way right now. You could do the whole zoop method and solve for x that way. Like you could go like this. Zoop. Log base 7 of 12 equals x. And then just use your calculator to get the decimal, because it's going to ask you for both decimal and for exact form. And if you don't remember where log base 7 of 12 is, you go math and you go down to log base and you hit 7 for the base and 12 next to it, and it gives you the decimal 1.276, and it'll tell you where to round. I think it wants you to round to like the third one. So x is equal to 1.277. Okay. So this one is super, super, super easy when it has just 7 to the x. If they change it on you like this right here, 5 to the 3x minus 1, 4, you can't really zoop, okay? Because you don't have something very simple. This is a much more simpler problem. It equals 12, or if it equals 4, you could solve it. But this isn't, these both have x's in the exponent on both sides. So we have to do this general rule, which is to take the ln or log of both sides. I prefer to take the ln because ln gets rid of everything. Now, you're going to look at this the first time I do it and you're going to be like, that's crazy. But I have another one underneath and you're going to try it together with me. So here's what I mean by taking ln. You literally put ln on this side, ln on that side. And why am I doing that? Because there's the power rule that says whatever your exponent is of an ln, you can move it to the front. So I'm going to move that 3x minus 1. I'm going to put it in parentheses to the front of ln 5. And I'm going to do the same on this side. That 2 minus x can go to the front of this ln. 2 minus x, ln 4. And that's the whole reason we do logs and inverses, so that we can drop that exponent down using the power rule. Now, ln of 5 is a number in your calculator. And what do you do with numbers? Well, you just distribute them. If this was just a 5, you would distribute the 5. If this was just a 4, you would distribute the 4. You're going to do the same with ln. And it's going to look messy, but it will get you the right answer. So I'm going to distribute ln 5 to each one of these. And watch how I write it. 3x ln 5 minus, and now I'm going to distribute the ln to the 1 ln 5. You really don't need the 1, but I just put it there. Well, I'm going to do the same thing on this side. 2 ln 4 minus x ln 4. Okay? Now, once you do the power rule, once you distribute, you want to get your x's on one side. Get all the x's to one side. So move everything over that doesn't have an x. So if you can see right here, this has 2 ln 4. This doesn't have an x, so leave him there. But this has an x. I'm going to add him over. This has an x, but this one doesn't. I'm going to take that one over to the other side. I'm going to put all my x's. I like my x's on the left. So this stays there, 3x ln 5. This minus x ln 4, I'm going to add it over. This minus 1 ln 5 is going to add over to that side. So 2 ln 4 stays. And that minus 1 ln 4 just becomes plus ln 5. So again, all I did was just get my x's to one side. Now this is the biggest thing right here. You're going to factor out on the left the x. Factor out an x. So see the x, I'm going to factor it out. And I'm going to be left with 3, an ln 5, a plus. If I factor out the x from here, now all I have is an ln 4. And then leave this side 2 ln 4 plus ln 5. And then all you have to do is now divide. This is just a number. It just looks, it's a terrible number. It's like a very ugly decimal, but it's just a number. And just divide it out. 3 ln 5 plus ln 4. And divide this side by 3 ln 5 plus ln 4. Now, they are going to ask you to clean this up. So they do want you to write this in an exact form. I believe, actually, I have to kind of check, but I wrote myself little notes that it seems like they do. And if you don't remember how to do that, it's kind of condensing. It's what we learned last class, meaning you take the 2 and you bring it up here. And so that would be the ln of 4 squared plus the ln of 5. And when you add 2 logs, what do you really do with those two numbers? You multiply them. So 16 times 5. So that's the ln of 80. On the bottom, you bring the 3 up to the 5. And that would be the ln of 5 cubed plus ln 4. And 5 cubed is 125. 125 times 4 is, I think, 500. That is the exact answer. And then you just use your calculator to get the decimal. ln 80 divided by ln of 500. 0.7051. And this is the decimal. And I think it asks for both. Okay, now let me just go through step by step again with you, because I know that it's a lot to process the first time you see it. It's not terrible. If you have algebra skills, you really are like, okay, it's not terrible. You ln both sides. You bring the exponent down. You distribute that ln of 5 on both sides, ln of 4. Get all of your x's to one side, everything that doesn't have an x to the other side. Factor out the x. And then divide by that. And then you obviously it's cleaning up. Just to show you if you did it right, you can put the left side, which is 5 to the 3x minus 1, into your Desmos, and then 4 to the 2 minus x into another part of Desmos. So just to show you, I'm going to write 5 to the power of 3x minus 1. Oops. 3x minus, come on, you need a parenthesis. 3x minus 1. On this side, I'm going to put 4 to the 2 minus x. And I'm going to look for their intersection point, which is right here, which is 0.705, which is exactly what I got. So I know I did it right when I did it analytically. All right, let's try one more of those. I know they're complicated. I'm going to go through the whole process again, but you're going to have to just do it. Again, if it was something easy, like you could even do this process to that. You could ln 7 to the x, ln 12, bring down the x. And then all you'd have to do is just divide out that ln of 7. And ln of 12 over 7 is just a change of base. Remember, that's the log of whatever the base is of the big number 12, which is what we got. You could do both ways. All right. So let me do this one real quick. I just wanted to show you that. But again, process is take the ln, take the ln. Whatever you do to one side, you're doing to the other side. Bring the exponent down in front. X minus 5, ln 2. Bring the 2x down in front. 2x, ln 3. Distribute your ln if it can be. Let's see, this one was already distributed. There's no plus or anything. So this would be x ln 2 minus 5 ln 2 equals 2x ln 3. So I did my power rule. I brought it down. I distributed my ln. Keep all your x's on the left and numbers to the right. So this would be x ln 2. Oh, this one has an x also. So let me minus that over. And then let me bring this one to that side. Let me bring the minus 5 ln 2. So that's 5 ln 2. And now you're going to factor out an x. You're left with ln 2 minus 2 ln 3. And then you just divide out that coefficient in front of the x. ln 2 minus 2 ln 3. Now, I'm not sure, somebody might want to check for me, I don't know, but I'm not sure if they would accept this as an exact answer. I know I do, but I think everything that I'm writing seems to be getting it down further. So just to go simpler, you can call that 5 to the power of 2, which would be ln of 2 to the 5th, which is just ln of 32. And then I'm going to do this power first. So this is the ln of 2 minus the ln of 3 squared, which is 9. And when you subtract, you actually divide those two numbers to condense it. So this is the ln of 2/9. Ooh. And so that would be the exact. And then you can punch that in your calculator. And I'll just tell you what I got. I got negative 2.304. But do you see the process? It's literally the same thing. ln, ln. Distribute that ln of whatever it happens to be. Get all your x's to one side. Factor out the x. And divide. And it's the more you do it, the better you will get at it. I promise, I promise. All right. And with that, we'll take a little quick break right now. And we'll come back. Like I said, we got a little bit more to do on this lovely section right here. But we'll give you about 10 minutes. So we'll come back at, well, actually, I'll come back at like 6:55. I got my dog. I'm going to kill him. He's destroying my lovely thing right now. My office. Okay, let me get back to this lovely worksheet and get going. I told you we got a lot of extra problems to do tonight. So let me share my screen. Okay. So again, you're gonna undo these exponentials with logs. That's what gets them down. The logs will get those exponentials down. So let's do two more examples real quick here. You do want to get the exponential part by itself if you can. So see how this has a +1 here and there's a 2 in front. Get it as much as you can by itself. So like subtract the 1, 2 times 2 to the x minus 1 equals 48. And then this 2 right here, you can actually divide out this 2, not this one. This is the base that has the exponent. I'm going to divide out the 2. So now I have 2 to the x minus 1 equals 24. And now you have it in the form that we were solving from before. So we can take the logs of both sides or ln it. I prefer to ln it. So you can ln, whatever you do to one side, you have to do the other. That will bring the exponent down. So you have x minus 1, and notice how I put it in parentheses, ln 2 equals the ln of 24. And I'll tell you what most students do wrong is they forget this side is being ln'd. You know, don't forget there's an ln in front. And then you can distribute right now and then subtract and do what I was doing before. But really, this ln2, since you don't have any other x's to deal with, you can just divide out the ln2. And then you have x minus 1 equals ln 24 over ln 2. And then you can just add the 1 on the outside of it. Totally allowed. Ln 24 over ln 2 and then plus 1. And I wrote that it's equivalent to 5.585. Because again, they're going to ask you probably for both. But there's another example that they'll do tonight. Just get the exponential part by itself before you take the log. Don't just take a log right now on this side and this side. You have to get that x part. You know, it's just something you should know by nature. Where I isolate the variable is what you may have heard from your teacher. Isolate the variable. Okay. Same thing here. Isolate the variable. It is. So let's ln both sides. Bring that x down in front. X ln of 6/7 equals the ln of 6. And this one's really easy. Divide by the ln of 6/7. And don't think that you're allowed to cancel any of these things. That's just how you leave it. You actually just type it in your calculator just like that. You know, you type ln 6 divide ln of 6/7. And you get negative 11.623. So ln of 6 over ln of 6/7, which is negative 11.623. Okay, so get the exponential part by itself. Get the exponential part by itself, which leads us into the next example. I know I have a lot of examples, but I'm trying to make sure I did a lot of what this homework was about. Now we have e's. Oh, how do we undo an e? Well, we ln it. So e and ln are the inverses of each other. Excuse me. You want to undo an e, you ln it. That's why I keep lning things. But if you want to undo an ln, you e it, which I will show you how to do in a minute. Let's start with this problem. What do you want to do? Get the x part by itself. Always, always, always get x by itself before you start doing any logs. Okay? So see this 3? You can minus it to the 8. 4e to the 5x equals 5. You can minus that 3 over. Hey, that 4, you can divide him out. You want that e to be by itself. As much as you can, get that exponential part by itself. E to the 5x equals 5/4. And now to undo an e, you ln it. Just like all the other exponentials we've been doing. But the cool thing about this one is, if you remember, the ln and the e cancel each other. They cancel to 1. And this just drops down in front. So this is just 5x on the left side. But on the right side, this is the ln of 5/4. And then you're just going to divide by 5. But really, when you divide by 5, the way they want you to write it in Pearson is they actually want you to write it like this. X equals 1/5 ln of 5/4. Dividing by 5 is the same as multiplying by 1/5. So make sure for this question, you write it as 1/5. Look at your notes when you do the homework like I'm doing right now. And write it as 1/5. Like if this was a 2, it'd be 1/2. If this was a 3, 1/3. Because when you divide by 3, it's like multiplying by a third. And this is how they want it written. Okay, so just a little note right there. A little star. All right, what about this one? An ln. How do you undo an ln while you e it? And what does that mean? So again, you're going to get this ln portion by itself as much as you can. There's nothing you can do with the 9. That's attached to the ln. But this 5 you can get rid of. So just divide that out. ln 9x equals 2. So to undo an ln, you e it. What that means is you raise this side to an e power, and you raise this side to an e power. You e it. You don't multiply by e. E to the ln of something cancels, and then the ln of e, like this right here, cancels. E to the ln will cancel. So we raise this e as the base on this side and base e on this side. And what'll happen again is the e and the ln will cancel, and that 9x will just come down. That's just a property. This side, however, will remain e squared. And then all you have to do, divide by 9. And that is your answer right there. E squared over 9. All right, some more logs. I always want you, and I always say this to my students, to look for a single log is what it's called. If I have one log on one side, you're going to do the whole zoop, 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 one log, one side. One log, one side. Do the whole zoop, one log, one side. So what do I mean? Let me change colors here. You're going to do left side 6, wrap around to the 1, equals this whole thing. 6 to the 1 equals 3x minus 7. So, I wrote 6 to the x, 6 to the 1, whoops, which is just 6. So add 7 to it, would be 13, and then divide by 3. X is 13/3. Very easy. One log, one side, whoop, wrap it around. Same thing here. One log, one side, wrap it around. And notice how my log is on the left. That's how I like to wrap it around. So 2 to the power of 2 equals, what's next to the log? X cubed minus 4. And so what is this? This is 4. And then you add 4 to it and you get 8. And they take a cube root and you get 2. Just make sure that whatever you're getting, if you were to put it back into here, you're not allowed to be 0 again. This thing next to the log cannot be 0. So even this one up here, I should have checked it. 13 over 3 times 3 is 13 minus 7 is 6. The log base 6 of 6 is 1. And then if I plug 2 in here, this is 2 to the second. 2 to the third is 8. 8 minus 4 is 4. Log base 2 of 4 is 2. Okay, so just make sure if you plug it in that it won't get you a 0. Righty? You will have some using properties of logs. And what do I mean by that? I mean, again, condensing. If you see a bunch of logs, you really don't want a bunch of logs. You want one log, one side, one log, one side. If you can get it to be one log on one side. So condense and then solve. Condense and then solve. So on this side, I want to condense this to be one log. So how do I do that? Well, if I'm adding, I really just multiply these two and condense it. So it'd be ln of x times x squared, or x to the third, equals 3. Ln of x to the third equals 3. Now, could I bring this 3 down? Yeah, sure. Could. 3 ln x equals 3. Could you divide out that 3? You sure could. You just can't touch anything next to the ln unless you do its inverse operation, which we'll do in a minute. So this is ln x equals 1. Now, how do I undo an ln? I e it. What does that mean? I take this side and raise it to an e. I take this side and raise it to an e. To undo an ln, you e it. To undo an ln, you e it. Okay? And then this will cancel, and you'll be left with x equals e to the 1, or just e. X equals e to the 1. And again, you just want to check to see that this won't make it 0 here. Nope, e squared is good. And an e there, that won't make it either. Okay? So pretty simple. Let's do this one. Log base 10 of x plus log base 10 of x minus 15 equals 2. Again, I want to condense this side to one log. So log base 10, when I'm adding, I actually multiply x times x minus 15, which is really x squared minus 15x equals 2. And now I'm going to do the whole whoop, wrap it around. Because I see once I have one log one side, whoop, wrap it around. So that would be 10 squared equals x squared minus 15x, which is really 100. So anything with squares, though, I'm going to set equal to 0. So this would be 0. This would be x squared minus 15x minus 100. And then I'm going to have to factor it, hopefully not quadratic formula it, but I don't think so. I can already think of two numbers that multiply to 100 but make 15. So that would be 20 and 5. And this has to be negative and this has to be positive. So then my two answers for x would be 20 and negative 5. Now, just like everything else we've been doing, when you get two answers, you better check that both of those answers work back into the original, okay? So if I plug 20 in, I'm not going to get anything. It's always going to be greater than 0, so that's going to be good. Log base 10 of 20 is fine. Log base 10 of 20 minus 15, well, that would be 5. That's still good. But this negative 5 is not going to work. That's an extraneous root because you cannot take log base 10 of negative 5. I mean, you can check it right now. This will be log, if you just hit log of negative 5, that's log base 10 already. But look what it says, error, not real. Okay, so you have to make sure that what's inside of here has to be greater than 0, greater than 0. So x equals 20 is the only answer for that one. Okay. All right, moving on. Let me tell my son real quick. Can you shut that door for me, please? Okay, I'm not done yet, though, sweetie. Okay.
I know.
Bye, honey.
Hmm?
All right, I love you too. I'll talk to you in a minute, okay? Take Jack with you. He's driving crazy. Sorry about that. Shut the door. Thanks, bud. Okay. You will get a all variable equation, and you're going to be asked to solve for it. And specifically, you're going to be asked to solve for this guy t right up here, which is the exponent. And the only way to bring down an exponent, y'all, is to do a log or to do an ln. Okay. And so I'm going to show you how to do this real quick, the best you can. But you want to get as much as you can this part by itself, the part that has that exponent. Meaning, there's a q right here that you could actually divide out. So this is 1 plus p over m to the tm equals a over q. Okay. Now, to undo, again, we're solving for t. To get that guy down in front, you have to log both sides or ln both sides. I'm actually going to log this time. I don't think it would matter, but I'm just going to write the word log on both sides. And what that allows me to do now that I've written log on both sides, it allows this to come down in front of the log because it uses the power rule. So I have log of a divided by q equals t m, and then the log of 1 plus p over m. I mean, it looks really complicated, but if you're kind of following along, that we can take a log and it brings down the exponent. So now what ends up happening is, again, we're solving for t. Well, this is multiplication and this all is multiplication. We're not solving for anything inside here. So we're just going to divide all that out. M log 1 plus p over m. We're going to divide it over here. M log 1 plus p over m. And that right there is your answer for t. I'm not going to rewrite it again, but that's it. That's all you have to write. It looks complicated, but if you can, again, get the exponent part, the part that has the exponent by itself as much as you can. If there's like a letter here in front, you can divide it out. It's not a terrible problem. And then you just log both sides and it makes it very, very, very easier, much easier. Okay, now we're going to do some solving equations in quadratic form. And these will look trinomial. So this is how the beginning of this homework will be. And then we get to do some graphing things. Yes, there we go. Okay. Solve an equation in a quadratic form. So quadratic form, again, being like, something that looks like ax squared plus a bx plus a c. So it's got like 3 terms and you set it equal to 0 and you can solve it that way. Well, surprisingly enough, this is in a quadratic form. Do you remember doing that u stuff last time? I know it wasn't a pain. It was a pain for it, but we're going to kind of do that again here. So e to the 2x is actually the square of e to the x. So if I let u, again, they like to use u, so I'm using u, be e to the x. And I square both sides, u squared would actually be e to the x squared or e to the 2x. Oh, that's that right there. So this is really u squared. This is really my u, and this is plus 6. And that is a quadratic form, which is factorable. And so I can factor it. What 2 numbers multiply to a positive 6, but add to a negative 5? And that would be -2 and -3. And then if you solved, you get u to be 2 and u to be 3. But remember, what is u? U is e to the x. So this side right here is just e to the x equals 2. And this side is e to the x equals 3. but you have to solve for it. How do you solve for e to the x? Well, you ln it. Remember, to undo an e, you ln it. To undo an ln, you e it. To undo an e, you ln it. Okay, so we're going to ln both sides. And the ln e cancel, so x is the ln of 2. On this side, ln, x is the ln of 3. And there's how to solve a very basic e to the x quadratic form. Oh, but there's so many more. This chapter's full of them. So you want to look for them. You definitely want to look for like an e to the x, e to the 2x. And so again, this one has e to the x and e to the 2x. It has the 6 on this side, but I can easily bring that over. 2e to the 2x plus e to the x minus 6 equals 0. And again, I'm going to let u be e to the x. So this is really 2u squared plus u minus 6. And so I got to do the whole factoring thing. What two numbers multiply to negative 12, but add to a 1? And that would be 4, negative 3. But because there's a 2 in front, I got to divide by 2. So this reduces to u plus 2, but this one can't reduce, so I bottom it up. 2u minus 3. And then I set each one of these equal to 0. U plus 2 equals 0. That's the zero product property. 2u minus 3 equals 0. Again, you should know how to do all that. That's factoring. But now, instead of u, remember, what did we let u be? We let u be e to the x. So this is really e to the x equals negative 2. If I subtract that 2 over. Well, here's my first problem. Just to show you, if I try to ln this and ln this side, you can't have an ln of a negative 2. We've talked about this already. Whatever is next to log or ln has to be greater than 0. It can't even equal 0. It has to be bigger than 0. So this can't happen. That cannot happen. So let's see if we get an answer on this side, because if not, we have no solution. 2u equals 3. U is 3 halves. U is actually e to the x. So I ln, yes, that will work. The ln of 3 halves works. Okay, so be very careful about that. You can't have a negative that it's equal to. It's just not going to happen. Okay, here's another one in this quadratic form. And they put a lot of these on here. I was surprised. I was like, wow. So like I said, I'm trying to show you all of them. 2 to the 2x, there's that 2x, minus 12 times 2 to the x plus 35. Well, instead of me having e to the x, I have 2 to the x. E is actually 2.7 to the x. So now I'm going to let my u equal 2 to the x. And so what that does for this one right here is this actually is u squared. 2 to the 2x would be u squared. Minus 12, this is 2 to the x, which is u. That's what I let u be, plus 35. And I do exactly the same thing again. You got to look for these. They're tricky because they look so complicated. But if you see 3 terms, set it equal to 0. And then be like, I bet this is a trinomial. And it's usually the middle term is what you call your u. And then just to show you again, this would be u. 2 numbers that multiply to 35, but add to a negative 12 would be negative 7, negative 5. So u equals 7 and u equals 5. And then again, once you get to that point, once you get to this point right here where you have your answers, don't type in 7 and 5. That's not the answers. because u represents 2 to the x. And so now you have to solve these. And how do I solve them? This one's actually very easy to solve. This is already in an exponential form. You could ln both sides. You could, and bring down that x. Or you could realize that you have the whole zoop. So this would be x equals log base 2 of 7. That's what the, and point to the x equals x. So that's the one answer. Just to show you this one, again, you could ln both sides, bring down the x. So x ln 2 equals ln 5. And divide out ln 2. So you'd have ln 5 over ln 2. However, they want you to do it on change of base way, meaning they don't want it in this form. They want it in this form right here. So you would just write log, whatever your bottom number is the base, and the top number is what it's next to. Okay, so I just showed you 2 ways to do the same thing, to get the same answer on both sides. If it's just like 2 to the x equals a number, you can just go zoop, right around, zoop, right around. 2 to the x equals 5, zoop, log base 2 of 5. Okay, but you could do what we were doing on the harder problems, which was ln both sides, and then bring down the x, and then divide out the ln 2. Also acceptable. But just so you know, on homework tonight, they want this, they want it written like that. Okay, so there's some solving equations in quadratic form. Oh, wait, there's one more. I didn't realize it's on this page. Here's another one. I know I told you, I was like, wow, I really did a lot. Log base 2 of x squared plus 2 log base 2 of x equals 15. You know, anytime you see a squared or a e to the 2x or and an e to the x in the same thing, these trinomials come up. 1, 2, 3 terms. Set them equal to 0. Log base 2 of x minus 15 equals 0. This time we're going to let u be log base 2 of x. Last time we let it be e to the x. Now we're just going to let it be log base 2 of x. The other time we let it be 2 to the x. I mean, again, you could do this whole u trick for a lot of things. When you have like multiple things, multiple logs or e's, you can do it like this. So this part, this first term would be u squared. This would, middle part would be 2u minus 15. Let's go through this again. Let's factor this. U and u, 2 numbers that multiply to negative 15 but add to 2 would be positive 5 and negative 3. So u is going to be equal to a negative 5 and u is going to equal a 3. And once you get to that point, replace your u. Log base 2 of x equals negative 5. Log base 2 of x equals 3. Now, this, when I go to do the zoop, once I have one log, one side, one log, one side, you're going to go zoop. 2 to the negative 5th equals x. 2 to the negative 5th is an actual number. Remember, that's just the same as saying 1 over 2 to the 5th. It's supposed to be a 2 to the 5th, which is really 1 over 32. One log, one side, zoop. So this is 2 to the 3rd equals x, or x is 8. And again, just double check plugging those back in that they don't make zeros, and they don't. Okay, so, oh my, lots of questions on u substitution things, which I was like, wow, but you can get it done. All right, I think we're into some graphing, and yes, we're almost done. A little bit of application problems, but you really got to practice this. Given f of x equals negative 6 e to the x plus 11, what is the solution to f of x equals 0, f of x is less than 0, and f of x is greater than 0? going to show you how to do this analytically. I will show you how to do it on Desmos. You do need the analytic part because you have to be exact when you type it into Pearson. So the solution to f of x equals 0, you just literally set this equal to 0. Negative 6 e to the x plus 11 equals 0. So that would be negative 6 e to the x equals negative 11. Remember, get that e by itself as much as you can. So I'm going to divide out that negative 6. E to the x equals 11/6. And again, how do I undo an e? I ln it. Goodbye. X equals the ln of 11/6, which ln of 11, whoops, 0.606, just to give you a clue because we're going to do it. Now, when you go to do this side analytically, you might think, oh, the answer is going to be, x is then less than ln of 11/6. And this one with x would be greater than. But there's a little trick of what happened right here. So I'm going to start actually from right here. I'm going to put negative 6 e to the x plus 11 less than 0. And again, if you minus 11, if you remember, when you divide by a negative 6, what happens to your sign? It flips. E to the x is now greater than 11/6. And then you ln it. You get x is greater than ln of 11/6, which means that your solutions would be from the ln of 11/6 to infinity. This one would be there. And then likewise, the same thing would happen on this side because you're dividing. You divide by that negative 6 and it would flip it to now be less than. And then you ln it. You get x is less than the ln of 11/6. So that would be from negative infinity to the ln of 11/6. Okay, so just something to be careful of here. You have to flip when you divide. And that's doing it, obviously, analytically. You could do this graphically. So let's show you on Desmos how to do this. Type in negative 6e to the x power, and then plus 11. And then I like to put y equals 0 on this line because that's where I'm kind of looking forward to it. Okay, so where they intersect, whoops, where the two colors intersect is where they equal. And look at that, 0.606, 0.606. Where the graph is below this purple line, where my green graph is below the x-axis, is from 0.606. And again, I know it looks like it's going just straight down, but it actually goes to infinity. So from 0.606 or the ln of 11/6 to infinity. So we did that right. And where was the graph greater than 0? Right up here from negative infinity up until 0.606, which is the ln. So we did all three of those correctly. So if those of you who like reading the graphs better, that's how to do it with the graph. And I know many of you like that. I'm actually going to do the next problem on my worksheet. Same way, I'm going to type ln of x plus 5. And we are comparing it to the y equals 0 line again. Okay. But I want you to notice something about this one. This is just crazy. So ln of x plus 5, remember it has an asymptote. It doesn't go past on the x-axis, it doesn't go past -5. Actually can't even be -5. All right. So where they're equal to each other is at -4. Look, they both cross each other at -4. But when we go to answer the question on the next part, which says, okay, well, where is the ln of x plus 5 smaller than 0? Well, everybody was like, oh, it's from, -infinity to -4. No, 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 no. There's an asymptote here. It's from -5 to -4. -5 to -4. And then where is it greater than? Where's the black line greater than 0? It's from -4 to infinity. -4 to infinity. And so let me just show you on the paper analytically what we're doing. So again, remember this x plus 5 has to be greater than 0. It just has to be. X has to be greater than -5. It can never be ever 0, and it can never ever be below 0. So for this part right here, ln of x plus 5 equals 0. This one's the easy part. How do I undo an ln? I e it. E and ln cancel. I'm left with x plus 5 equals e to the 0, which anything to the 0 power is 1. And then minus 5. And that's where I got -4. Now, that was easy to see on Desmos. You could easily see where they crossed off, but there's analytically how to do it. This part right here, this less than 0, okay? We did, if you do solve it, whoops, ln of x plus 5 is less than 0, and you do e it, and you get x plus 5 is less than 1, x is less than -4, you're mistaken because there's still this piece of information right here. You can be less than -4, but you have to be bigger than -5. So that's why your domain, or your solution has to be both of these. You have to be, for x, you have to be greater than -5, but smaller than -4 in order to be less than 0. So you would write -5 to -4. So don't forget about that one on this. And then this one right here, again, the ln of, x plus 5 greater than or equal to 0 would be, we e it. We get x plus 5 is greater than or equal to 1. So x is greater than or equal to -4. Now, I'm allowed to be -4. If I plug -4 back into the original, I won't get a 0 here. -4 plus 5 is 1, and the ln of 1 is equal to 0. So I am allowed in this case to equal -4. All right. But again, those of you who like to see the graph of it, you can always do the graph and make it. But that's analytically how to do it. You just don't want to forget that you're not allowed to, this domain right here next to the ln has to be greater than 0. All right, so a few quick little word problem-y things, and they're not terrible, and then we're almost done. And I tried to pick some questions that I saw them have, continually. But let's see, this says the amount of carbon-14 in paint after T years is given by the equation A of T equals A sub naught e to the negative 0.00012 T. The paint contains 28% of its carbon-14. Estimate the age of the paint. Okay, so for this question, we have paint that contains 28% of its carbon-14. We have some kind of paint right now. At A sub 0, which if you don't remember what that means the initial amount you had. Let's just say I had an initial amount. of 100%. Okay, or we had a whole can of paint. We don't know, but we can call it. Now the paint contains only 28% of its carbon-14. So the initial amount was 100% of whatever we had, or 1. And now, after so many T years, we're at 28%. Well, 28, oops, or 0.28. So that's what we have left. That's our A of T. So we have 0.28 equals 1. That was what we originally had, 1 of it, 100% of it. E to the negative 0.00012 T. And now, again, anytime working with E's, you get the E by itself. So that 1 really doesn't mean anything. You can divide it out, doesn't do anything. So how do we undo an E? We ln it. So we are going to ln both sides. Ln of E to the negative 0.00012 T. The ln and the E will cancel. This side will stay ln of 0.28. You'll get this crazy decimal here. And then remember, you're just solving for time. So let's divide out 0.0012, negative 0.0010012. Whoops, gotta be careful there. And ln of 0.28, and we are going to divide out a negative 0.00012. And I got 10,608 years. T is in years. So the estimated paint, that's kind of crazy. 10,000 year-old paint. But that's how you would do that problem. And they're going to have a problem just like that. I've seen it a couple of times. Even my students had it. You just call A sub 0, 1. You have 1 of 100% of it. Now you have left, what you have left is 0.28. And then simple as taking an ln. Then they'd like to do bacteria equations, because those again deal with these exponentials. And again, that's the whole point of logs. Given a bacteria equation, F of T equals A sub T e to the 0.026 T, where T is in minutes. And the initial amount was 2,700,000 bacteria. Find the number of bacteria at 5 minutes, 10 minutes, 60 minutes. I'm not going to do all of these. I'm just going to show you how to break it down. But really, T is minutes. So you're going to find F of 5, F of 10 minutes, F of 60 minutes, and so on. And you're going to plug it into the formula. This is my squiggles. And the initial amount was 2,700,000 e to the 0.026 times 5. And then you do the same for this one. This was a pretty simple, but I just wanted to show you how to do it. This one you do times 10, and etc. This one you would do to this e to the 0.026 times 60. And just to show you this, I'll do this first one up here. So you do 2,700,000. Let me make sure I didn't type too many. 1, 2, 3, 4, 5. Yeah. And then the E button is above the ln. So you have to hit second ln, E to the 0.026 times, we'll just do 5 minutes. So now we have roughly, I'm trying to think, I'm looking at what the answers that I did. I think I rounded it to the nearest 100,000. So this was 307,4836. 307,4836. 307,4836. And they're going to ask you to round it to the 100,000th, not the millionth, the 100,000. So this 7 would round that up to a 1. So I have about 3,100,000 bacteria. And they're going to make you do that for just all of these. So just, be careful of your rounding, but it's pretty easy just to plug it into a calculator and go. So that was the only one for that one I thought was kind of unique. I was like, wow, okay, they're making you round to 100,000 as opposed to decimals. Half-life equation, here they've given you a half-life equation, A sub 0 times e to the kt, where k is equal to ln of 2 divided by t. If the half-life decays after 31.3 years, how long will it take a sample of 500 grams to decay to 400 grams? Okay, so the first thing you need to do is figure out this K guy right here. Okay, because they've kind of given you two formulas. K, so here's, we'll say part A. K is the ln of 2 divided by time. Well, they told us the time is 31.3 years. So we're just going to do that. ln 2 divided by 31.3. Oh, I just messed that up. ln 2 divided by 31.3. 0.022. Now, if we are decaying, it's actually negative 0.022. If that makes sense to you, because we're getting less of it, so it's decaying. If we're growing, it would stay 0.022. So now we're going to use this K and we're going to plug it back into this equation. So A of t now equals A sub 0 e to the negative 0.022 t. And we're going to use it to answer the second part of this equation, which said, how long will it take a sample of 500 grams to decay to 400 grams? Okay. How long would it take a sample of 500? So that must be my initial amount, to decay to 400, which is my final amount. So this would be 400. My initial amount would be 500 e to the negative 0.022 t. And again, what this whole chapter has been about, get that e by itself, and we're going to have to do a log. Let's divide out that 500. 4/5 equals e to the negative 0.022 t. How do I undo an e? I ln it. I'm running out of room. Let me go up here. So this would be the ln of 4/5 equals negative 0.022 t. And then divide by negative 0.022. And let's check to see what I get for that answer here. ln of 4 divided by 5. And then I'm going to divide that by negative 0.022. 10.14 years. Or 10.14 grams. No, years. I was like, grams? I'm looking at grams up there, but no, it's time. Years. So something easy that you have to do, but you still have, you got to find that K first and understand that decay means that it's actually a negative value for that one. All righty. Last but not least, an exponential function, because regression models, we love those. Our last question here, given a table, estimate the CFC12 concentration. I don't even remember what that was. I just wrote it down. But model the f of x equals c times a to the x. And I'm going to put this in Desmos. Looking at what I did here. I think actually they told you to let x be 0. For 2005, let it be 5, 10, 15, and 20. So we're going to do that. And we're going to put it into Desmos. And let's see how Desmos will do it for me. And if you don't remember how to do it, I'll show you real quickly how. Go to my home screen. So you add a table. And I'm gonna, instead of 2000, I'm just gonna do 0, 5, 10, 15, and 20. And then here, I'm gonna put what they've given me, 0.72, 0.83, 0.97, 0.12, and 1.3. And I like to hit this little zoom fit right there. Look at that. Looks pretty linear, but we're going to, according to what they asked us to, model it with an exponential regression. So again, to write this in there, you would say y1, and it already does the sub for you. Put the little squiggle, put an A. They put C, but I just choose A. And then I do B to the power of x sub 1. And that's how I do my exponential regression. That's how I would type it out. My A, B, X to the sub 1. And then they give you your A, and they give you your B, and they even give you your R squared, which is 0.999. That's a pretty, very nice exponential regression model. And now we're just going to write this out here, and then we're going to estimate the concentration in 2016, which won't be hard. So let me go back to my So again, on Desmos, you do Y1 sideways squiggle, A, B to the X1. And then now they're going to use CNA, so don't get confused. You could probably CNA actually. I didn't even try it. I bet you could use CNA. I'll figure it out. I'll switch it up in a minute. But they're going to ask you for those CNA values. So this is 0.72. And this one is 1.03. So the model would be f of x equals 0.72, then 1.03 to the x power. And that's what you just have to write. And then if I want to estimate the CFC12 concentration in 2016, so that would be the f of 16, which is 0.72 times 1.03 to the 16th power. And you could easily use your calculator for that, type it in. Again, I would put parentheses. I know everybody always asks me, you're not multiplying these two together. You're multiplying this times 1.03 to the power of 16. So the answer will be 1.16 parts per million, parts per billion. Never mind. But like I said, just let me go back here to this one. And I bet you could change this to C and change this to an A. Let's see. Oh yeah, look at that. You can do that too, C and A. And it's not going to change or affect you at all. So that way you can stay consistent with what Pearson tells you to do. I just know that in the graphing calculator forces you to do it the other way. All right, friends, that's been a very long night. I understand. Just some quick comments real before you go. This next test is going to be really hard. And I'm going to allow just a little wee bit of